2.7 Solving quadratic inequalities. Quadratic inequality in two variables can be written in one of the following forms where a, b, and c are real numbers and a is not equal to 0. Its solution set is a set of ordered pairs of x and y. So we're going to jump right into some examples here. The first way that you can write it is you have example 2 is like example 2a here, where we have solving quadratic inequalities by just using a table or a graph. So we're going to solve this inequality, x squared plus 8x plus 20 greater than or equal to 5. We're going to use a graphing calculator to graph each side of the inequality. And if we were using our traditional graphing calculators like we have in school, then we would just set y1, or the first equation, equal to the left side, and we would set y2, or the second equation, equal to the right side. In this case, we're going to use the Desmos website because I know that you all have access to it. So when I go to the Desmos website, I can do x squared plus 8x plus 20. So that's my first part of the equation. Then for my second equation, I'm going to set that equal to just 5. When we do this, you're going to have to put y equals 5 in so it knows which one we're talking about. It would also help to put y equals this in, just so we get in the pattern of doing it. Okay, let's go back to the actual problem itself. It says x squared plus 8x plus 20 is greater than or equal to 5. So now we're trying to find the values of x where y1, or the first equation, is greater than the second. So when we look at this graph, we're looking for the values of x where the red is higher than the blue, or where my y values are greater than the blue line. If I click right in the intersection point of the two lines, I have -5 is my x value for this one, and -3 is my x value for this one. Between -5 and -3, my red is below the blue. So it's not greater than between those values. It is greater than from everything back here up to -5, and starting at -3 going on to infinity. So since it asked for us to solve this, that is our answer. It is going to be from -infinity, or every number, all the way up to 5, -5, and then a u, which means and. So from all the numbers from -infinity up to 5, up to -5 anyways, and from -3 to infinity. My red line is above the blue for every number back here. And if I keep zooming back, you would see it. But it never comes down. It's always up. I can even zoom in here, and it's still going to be going up. It never comes back down. Okay? So that's what tells me that it goes from -infinity to -5, and that's when that's when it touches 0, down at the bottom here. And from -3 to infinity, over everything to the right here, it's always going up. It's always above the x-axis. So you never see it come back down. You never see it go below the x-axis. It is always starting here, going up. The only time it's below this blue line is between these values here, between -5 and -3. We were looking for where it's above, so it's everything back here and everything from here on. So the parabola is at or above the line when x is less than or equal to -5 or greater than or equal to -3. So our solution set is x is less than or equal to -5, like we've been saying, or x is greater than or equal to -3. This translates to -infinity to -5. The reason we put a bracket on the end is because it has a equal sign underneath, which means it includes this point -5. Our u, which means and, from -3 to infinity. Solve the inequality by using tables and graphs. Here we have x squared plus 8x is less than plus 20 is less than 5. So we want to use a graphing calculator to graph each side of the inequality. Set y1 equal to x squared plus 8x plus 20 and y2 equal to 5. Then in this case now, because it's a less than sign, we want to find all the values where the first one is below the second one. So this is our graph of y equals 5. And this is our graph of x squared plus 8x plus 20. I'm looking for all the spots where it's below this line. So this whole section in here. So basically, I need to find where it's below. If I was able to bring a table up using our graphing calculator, I can see that when x is -7, y is 13. When x is -6, y is 8. When x is -5, y is 5. So I know that that's a spot where they're equal, is at -5. And -4, it's 4, so it's less than. And -3, our y is 5 again, so that means it's back to equal. Again, we can see it on the graph that it's going to be in between here where this equation is lower than this one. So this shows us that it's between -3 and -5. And that's every value that's in between there. So in order to solve this, the parabola is below the line when x is greater than -5 and when it's less than -3. So the solution set is -5 is less than x is less than -3, which would give us -5 and -3 with parentheses around it because it's a less than and there's no equal sign. If there was an equal sign, there would be brackets around both of those. Looking at the solution set, it would be an open circle with a line going up to -3 and another open circle. That means that it doesn't include the endpoints -5 and -3, because if we plug those in, they would be equal. Our next one wants us to solve the inequality by using graphs and tables. And again, it's 2x squared minus 5x plus 1 is greater than or equal to 1. I'm actually going to set some home values for this. I'll just just went back to the home circle. Get rid of my equations here. And I'll actually change this from -10 to 10. The step of 1, and then I'm going to change my y's the same way, from -10 to 10. And I'll do a step of 1 for each of those. Okay, now let's put our equations in. So I have 2x squared minus 5x plus 1. And then my other equation is just 1. So I do y equals. See, it's a good habit to get into. Without it, I messed up. And so now if I look back at what I'm trying to figure out, I'm trying to figure out where it's greater than or equal to 1. So my black is above the purple, starting at this point, going backwards. So it's going to be from -infinity to 0. And then it's also above it from 2.5 going to infinity. Since there's an equal sign underneath it, it tells me that it's brackets. It's going to be -infinity to 0. That's a bracket on this side. And anytime you have infinity or negative infinity, it's always a parenthesis. And then union 2.5 to infinity. So that every number to the right of this, the black is above the purple. Every number to the left of this point 0, the black is above the purple. The only place it's not is in the middle. And that's the part that we left out of our set. So the parabola is at or above the line when x is less than or equal to 0, or greater than or equal to 2.5. So the solution set is from -infinity to 0 and from 2.5 to infinity. If I was looking at this on the number line, it would be leaving out the exact same area that we had left out on our graph. So it's going to be going to the left, and it's a closed-in dot because of the bracket, and then it picks back up at 2.5, which will be in here, and goes to the right. So our number lines that show the solution sets in example 2 are divided into 3 distinct regions by the points -5 and -3. That was our first example we did. These points are called critical values. By finding the critical values, we can solve the quadratic inequalities algebraically. So in other words, we don't have to keep graphing these or drawing graphs, checking the tables, checking the number lines. What we can do is we can solve these from an algebraic perspective and move on from there. Seeing as how that's a whole new topic in itself, I'm going to stop here and we'll pick that up on Monday. So have a good weekend. I'll most likely get your quizzes graded over the weekend, so be looking for those scores to come into your Power School or your Google Classroom. And have a good weekend, reset, and we will get started on the algebraic aspect of this on Monday.